Let's look at this really interesting number, transcendental number e. If you were to graph on your calculator the following function, y is equal to 1 plus 1 over x raised to the power of x, you would get a curve that looked like this. Now it turns out as x goes off to infinity, this curve asymptotically approaches 2.718 yada yada yada. Now we are going to call this number e. It occurs so often in natural phenomenon in the world that it's got its own number, its own letter. Now there are ways you can evaluate e on your calculator. Suppose you want it e cubed. All the calculators have an e to the x key. You need to look at your calculator to see how it works. So if I want an e cubed, I would type in e and then the caret 3, depending upon your calculator. You could do a graph, and when you graph e to the x, come over to 3, and then you could put in the line y equals 3, find the intersection. You could make a table and do the approximation that way. Now, when you look at the e to the x graph, you see that it is exponential growth. Why? Well, y is equal to b to the x. Okay, in this case, when y is e to the x and e is approximately 2.71, that is greater than 1, so you're going to have growth. The domain is all real, and the range is y greater than 0. It'll never equal 0. Now, if you look at the maximums and mins on a closed interval, then what you need to do is evaluate the function at those points. So the minimum will occur at x is -4. So y is going to be e to the -4, incredibly small number. While the maximum will occur at 1.5. To find those actual numbers, you do need a calculator. So this is 1 over e to the 4th, or about 0.0183. And e to the 1.5 is approximately 1.4817. Now, if I wanted to graph this, y is 0.05 times e to the x. This is going to be a vertical shrink. The horizontal asymptote stays the same. The 0.01 gets mapped to 0, 1/2. Now I like graphing the second e squared. It's not an exact number, but with the magic of online programs, you can get some pretty close approximations. But you see, this is just going to be a shrink, so all of the y values will get reduced by a factor of 1/2. Now, when I have y is -3 e to the x, this is going to be a vertical reflection, TICAL, across the line y equals 0. And it'll be a vertical stretch, factor 3. So if this is my original y is e to the x, this gets reflected across the axis and stretched. While if I add this +2 here, just like with the other exponentials, this is going to move my horizontal asymptote from y equals 0 to y equals 2. And everything will be shifted up. There will be no change in the shape of the function. And finally, if I have something like e to the x plus 5, this is going to be a horizontal shift, left, 5 units. The horizontal asymptote stays the same. The entire graph just gets moved to the left 5 units.